So we're going to show here the solution to quiz 1. It's here. Zoom in. So, the solution involves identifying the electronic configuration of vanadium and of oxygen. Going back to our periodic table, we've got vanadium here and oxygen here. Oxygen is in the 2p, so it has partially filled 2p, 2s, and then 1s. And we're going to write this in compact notation that oxygen has the electronic structure of helium plus 2s2 and 2p, 1, 2, 3, 4. That's oxygen. Then vanadium. Vanadium has 1s filled, 2s filled, 2p filled, 3s filled, 3p filled, 4s filled, and part of the 3ds filled. And in a compact notation, we'll reference it to argon, Ar, plus the 1, 2, 3, 4, 4s2, plus the 3d electrons, and we have 1, 2, 3 of those. So oxygen is He 2s2 2p4, and vanadium was argon with 4s2 3d3. Okay. The next question is about the electronic structure of vanadium and oxygen when they're in their oxide, V2O5. Now, something interesting about vanadium is that vanadium can take tons of charge states. It can take +2, +3, +4, +5. And in fact, vanadium oxide is a decent charge carrier, not because it has the electrons that are free to move, because this is very strongly ionically and covalently bonded, but because if you have vacancies on the vanadium site, those vacancies can take multiple charges, and you'll have hopping of charges from site to site based on lattice defects. But right now, though, we're just interested in this particular compound. So looking at that, we know that oxygen is extremely electronegative from our chemistry class, and we know that oxygen always takes Al, always -2. Right? Oxygen's always -2, which basically puts 2 electrons additional and makes it, gives it the same electronic structure as neon. But what does that tell us about vanadium? Well, we know that this has to be charge neutral, V2O5, which means that 5 times -2, 5 oxygen atoms with charge -2, plus 2 atoms times some unknown charge is equal to 0. And the only way this works out is if this is +5, which means that our vanadium is taking a 5+ configuration, which means that from here we go 1, 2, 3, 4, and then back 5, and it has the electronic structure of argon. So we can get that by knowing that we have a charge neutrality, and then just counting the number of electrons that move, or that are added or subtracted. The final question is about the percent ionic character, and we have this equation 1 minus exp of minus xv minus xo squared over 4. That's the equation we have. This gives the fraction ionic character. To get the percentage, you have to multiply by 100, and I didn't put that on the equation sheet. Truth of the matter is they're both equivalent as long as you know whether or not you're presenting a fraction or percent. Someone may have a question about how did I put vanadium here versus oxygen? Can they be switched? And if you look at it, we're just taking the difference and we're squaring it. So whether this is a positive or a negative value is always going to come out the same because of the square. So the reason the square is in there is to remove that question about should it be V first or O first. Okay. The electronegativity of vanadium here is 1.63. The electronegativity of oxygen from here is 3.44. Therefore, 1 minus exp minus 1.63 minus 3.44 squared over 4, and kind of turning the crank gives us 0.5591 stuff. Well, we have these out to 3 significant figures. So that says that we'll either call this 0.559 fractional or 55.9%. And that's how we solve the last part of quiz 1. There you have it.